This is the time of day intervalometer Arduino sketch. This is version 12-16. Added some things since the first video that I made. I'm not going to go through all of the code because there is a lot of it. There's about, let's see how many lines. This is about 1,473 lines. I'm not going to do that. I'm just going to hit some specific areas to show how I did. All of this code will be available at this link, so you can go download it and play around with it and see if it works for something you're working on. I do want to talk about the libraries that I've included here. The DS1307 new is written by this guy Marvin, and it is what drives the TinyRTC module. There was apparently an issue with the TinyRTC module saving the time that you set, so his library and some of his code, which is available on this website, is what allowed me to fix that issue, and now the TinyRTC is working perfectly. Another one's EEPROM anything. It's available here, and that is a code library for reading and writing EEPROM. It allows you to essentially give the EEPROM anything code anything that you want, and it will handle assigning memory addresses to it. Also, when you're writing something, it will check and see if the thing that you are writing is already exists in EEPROM, so you don't have to write over it, which saves the life of the EEPROM, because there is a limited number of writes that you can make to EEPROM before it wears out. So here's some of the real-time clock stuff from Marvin. This is all directly from him. This is how you have to control the clock. What it does is it writes to the NVRAM of the real-time clock module, and it sees if it sets a bit to tell if the clock's been set already. If not, then it will set it to this time. If it isn't set, that's if it's not set. If it is set, then it just reads whatever it's set to, and then outputs that as your current time. This function void read buttons is what reads the actual 4 buttons. Because I'm only using one analog pin to do all 4 of these buttons. This code allows me to read the voltage coming from the buttons, and then to determine which button is pressed. So it's analog pin 0. So we set Y to the value that we've read, and it breaks the voltage, which would be from 0 to 5 volts. It breaks it into 1,025 steps from 0 to 1024. To actually get these values, I suppose you could do some calculations with resistor values and voltages and whatnot, but the easiest thing to do is to write a sketch to just print these on a serial console. So as you push the buttons, you'll just be able to see a scrolling list of numbers, and it'll tell you what the voltage is essentially, or what the value is coming from that analog read. So that's what I did. I built my rig, put a small piece of code on it on the Arduino, pushed the buttons, and then just wrote them down. And that's how I figured out this. So here, if Y is less than 15, there's obviously no voltage, so the button state is 0. And then this bit of code, which is repeated in all of these, it saves the variable last_st as the current state, and then it compares it, which means that it won't continuously say button state is 0. It'll just say button state 0, and then won't set it again until it changes. If you don't have this code in here, your button state variable will be continuously updated with this number. So this allows it to only only write a value to the variable on a change. So this is for the enter button. If it's less than 22 and greater than 17, because there is some variation in the button, if you especially the little tactile buttons I was using in Prototype, if you push it harder, you had more voltage. The buttons that I actually ended up using are a little bit better. They vary about 1 or 2. So I grabbed the middle one, I think it was about 20, and went in one direction for each. Maybe it was 21 and went 3 directions. So this sets the button state to 1, which is enter. And then this code right here, last interaction, is the variable I use to determine whether or not to turn off the LCD screen. And so if I'm pushing a button, I don't want the LCD screen to turn off. Down here, this is for up. So up was a value of 42, so I went from 41 to 43. Down is the same, down was 91, so 92 to 89. And then escape, escape has no resistor, so it's it should be 1024, but I just put from 1020 to 1024. This is show menus. There are several menus in here, starting at menu 0. For this, I use a switch case. I find it better, a little bit easier than an if-then statement, because it would be a very large if-then statement. It's a little cleaner and I like it better. Menu 0 is welcome. There's no cursor on the home screen. Cursor's off by default, I believe, in the LCD, the liquid crystal.h library. I believe it's off by default. But if you're going back to the welcome screen from a screen that does have the cursor, you want to turn this back off. Cursor then also gets set to 0. I write some spaces, and then I show the time. Then this byte 0 is actually, this is a custom character that I built, just a little right-facing big block arrow. LCD showtime is a function that came, I believe it came with the time.h, or perhaps the DS1307 new. Either way, it reads your real-time clock and displays the time. So if go is 0, then I write a space and show the date. So that's if we're not right now in the interval, in the shots taking mode. If it is, if we are taking frames currently, then it flips between the word running right here and the date. So the time is always on the first line, but I'm setting my cursor to the second line and then either writing the date or flipping between running and date. And to do that, I read the millis, which is the milliseconds since power up, subtract it from a variable I'm calling last update b, and if that is greater than or equal to 3 seconds, or 3000 milliseconds, then I write running, and I set x to 0. So if x is 1, it writes running, and then sets x to 0, and once it checks it again, x will be 0, and it'll write the date. But then it set x back to 1, so the next time it comes around, it sees it prints running, then it prints the date, and flips back and forth every 3 seconds. This menu right here is an addition. This is a new thing in version 12.16. This is the manual start and stop. It's actually fairly simple. If right now we are not running, if the intervalometer isn't running, then I print the words manual start. Otherwise, it's manual stop, because there's no reason to have manual stop if you're already stopped. And then, of course, press enter at the bottom so that push enter and it'll start or stop. There's probably a better way to do what I'm doing here, but what it's doing is it's converting hours, minutes, seconds to milliseconds, because I need to use that for the frame delay, because it's set in an hour, minute, second format, but it actually needs to be read as a millisecond delay. So this is an unsigned long variable because we are dealing with milliseconds, and it was recommended that always use unsigned long for milliseconds because they can't get quite large. This function takes h, m, and s, hours, minutes, seconds, and it returns a result. What it does is it multiplies hours by 3,600,000. It multiplies minutes by 60,000, and it multiplies seconds by 1,000, and then it returns a result in milliseconds. So it multiplies those and then adds them together. So this goes the other direction. This goes milliseconds to hours, minutes, seconds. It takes one value in. That would be a a millisecond value, and it returns 3 variables: temp hours, temp minutes, and temp seconds. And this uses number of hours val. So essentially, it takes this is declared else up higher before the first function for number of hours, number of minutes, and number of seconds as some math. But it brings in your value, and if it's more than a certain number of, if it's hours with remainder, it kicks that to minutes and seconds. So you're not going to get like hours 10.5. You're going to get 10 and 30 minutes. Last function I want to talk about is the process buttons function. Again, this uses a switch case to change the behavior of your buttons based on what menu you're in, because each menu does have a different. The buttons do different things, in each menu. The basic one is here on menu 0, your welcome menu. If you hit the down button, you increment your menu to the next one, which is case 1 down here. If you go up, it's going to loop back to the last menu, which is at the bottom. That's case 6. In the something like this is clocks. This is menu 1, sub 1. This is setting your clock. Enter increments that cursor position. There's only 5 cursor positions, or well, there's 6. It starts at 0. So there's 6 cursor positions, including 0. So once it gets to 5, then it actually sends you to the next submenu. So that's what this menu state equals 3 does. Cursor position equals 0. That resets your cursor back to the beginning. And then set RTC, this is specific for this menu because this actually is the clock setting. So when you're done adjusting your variables, then hitting enter will call the set RTC function and actually put those variables into the real-time clock. Here for up and down, depending on your cursor position, which actually, now that I think of it, this could have been a switch case as well instead of an if-then. Because this is based on cursor position. So cursor position 0 is hours. So you're going to be setting hours. Cursor position 1, that's setting minutes. 2 is setting seconds, etc. And of course, I have this loop. So if you're going, this is the up. So if you're going up and it's less than 59, then you add. But if it equals 59, it loops you back around to 0 because obviously there's not, anything more than 59 on the clock. The same is true for down, except we subtract and we loop back up to the top instead of to the bottom. This is our frame delay. This is where we use our HMS to milliseconds because the frame delay is expecting milliseconds, but the way we set the frame delay is with an hours, minutes, seconds format. This is the code to save this variable setting to EEPROM anything with the EEPROM anything library. The manual start menu is a new menu. This is an addition for version 12-16. Essentially, if you're not already running and you hit the enter button, it runs it. If it's not running, or if it is running and you hit the enter button, it sets it's not running. So that's pretty much it. Again, this code is available at this address, and I encourage you to write comments about what I could have done better, and please use this for your own projects if you found anything useful. Thanks.